Hello. Um, Today I'm going to show you how to um, install Rust, um, how to get started with using Rust, what are the drawbacks, what are the benefits, what are some cases that you have to watch out for. I'm trying to do this stream every Sunday at roughly 6 p.m. So that's well, that's what we are going to do today. So what we are going to do today is installation, and so basic programming, variables, if-else statements, loops, and yeah, those basic kind of things. Later on, we will get into memory management. We will get into multi-threading. We will get into lots of other cool things. So right now I'm more or less waiting for people to join the chat, but I'm trying to speak as clearly as possible. And I hope the audio is okay. So installation, basic variables, statements. Then we will go over loops and structures, as well as public, private sort of thing, as well as modules. Maybe we'll get to do modules, because those are the basic principles of using Rust and getting something done. It's not advanced topics, but it's just really basic stuff. So this will work on any OS. So it's multi-platform, cross-platform, then we have, so this will work on any operating system. So is there anyone watching this? Well, not right now, but so the installation of Rust. Right. So to install Rust, you can just go to www.rustlang.org, and it should have a big install button. If you click it, you will, depending on what operating system you have, it will either, on Windows it will show a downloader, or on Linux it will show a command that you can copy and paste into your terminal. So on Linux or on macOS, it's the same on Linux and macOS. You pretty much copy and paste this command. Now I am not going to do this. One thing that I wanted to say that you have to watch out is simply, so what this is it would, on Windows you don't have to listen to the next 5 minutes, but there are two installers for Linux and macOS. One is rustup.rs and one is rustup.sh. So if you so this is the actual correct installer. The difference is that if you the Rust tools may not be directly in the in your path variable. So if you usually if you execute a program such as, let's say, curl from the command line, because in the end that's what our programs do, they execute something on the command line, right? Where is curl located? So you can see that curl is located in user bin curl. This is the same thing as on Windows. Windows has the same concept, but it's hidden somewhere in the system settings. Now, the path variable is basically lots of these paths separated by a colon, and you can see that user bin is in one of these paths. So there is where the command line looks for this curl command, and if it sees something like curl.exe on Windows, or just on Linux they don't have extensions, so it's just curl, it will execute the program. The same is the program that you have to install in order to use Rust is called the Rust compiler. Rust is a compiled language, meaning that it's directly there's no intermediate interpreter, or it's directly outputs just assembly, and it just creates an executable file, and you can run the executable file. Right. So what you have to make sure is that if you input Rust C, you get something that looks like this. So if you run the installer for the first time, you will be greeted with options to configure. It will open a console, a terminal window. On Windows, it will open a console. If you have this if this doesn't show any output, you will have to modify your path variable, because you have to basically make sure that so in my case the Rust C is in home felix.cargo bin Rust C. This .cargo directory in Windows, I think it's in your documents folder. So this will be created once you install Rust. So there are two commands that Rust installs. One is the Rust C command, which is the actual compiler, which takes your Rust files and compiles them into something executable. And the next command is called cargo, and we will cargo is a package manager for Rust, which so that you can install other people's code and use it on your computer without larger problems. So, but for now we will only use Rust C because it's simpler and it's easier to understand without any notice. So I hope you can somehow use your terminal or command window. I'm just doing this to I am just doing this to show you what's actually happening behind the scenes, and then later on you can decide for yourself if you want to use a graphical tool for configuration or whatever. So to install Rust, again, just rustlang.org, and then you are basically greeted with an install button. If you click it, on Windows you get an installer, on Linux you get this command, and Mac OS, again, this is cross-platform, it will work on pretty much any operating system. So you just paste the command, and I'm not going to do this because I already have the Rust installed. So if you have Rust installed, just make sure that Rust C outputs something that looks like this. Right. So now I wanted to talk about how Rust works, how to get started, and we're just going to compile our first file. So take any text editor and just make some file. It doesn't have to end with rs, this is just a file name. Take any text editor, you can take Notepad or whatever. So all you have to do is to write fn main, then two opening brace, closing brace, then a curly brace, print ln, then this is a macro, actually a Rust macro, but this is important later on. And then you just write hello world or whatever name you want to output here. This will just print something out so that you can make sure that Rust is working on your system. And then don't forget this closing semicolon. So this is the most simple Rust program that actually does something. So what we're doing is we're telling, okay, Rust, please take this file and make it into something that is executable. So here I have this hello01.rs file. Right. So all I want to do is to say rustc hello01.rs. You just have to specify the file name of the file that you have to compile. If you have multiple files, this will get a bit more complicated, but for now we just limit ourselves to one file, and we'll show you how to do multiple files and directories and whatnot later on. So if you execute this, what you should see is that it has generated an executable. On Windows this will be an exe file, but this is just called the same name as our file. So, and if we execute this on since this is a console only program, I think you have to use the command line in Windows to do this. But basically you switch into this directory, and then you just write the name of the executable. So on Windows this will be hello01.exe, right? And then it will start this program. So what I'm going to do here is just say on Linux and Mac you have to say // so that it knows that hello 01 this, yes, because if it thinks this is for commands that are installed on the system, so to execute something from this directory we are just going to say // hello01, and it will print out whatever you specified here. And this is basically how you just do basic print statements. So just output something to the console. So this will not be visible in any way, no pop-up box, but this will just print something. Right? So now now I wanted to go over what this means, and sort of if you already know what a function is, then you may this may be a bit too advanced for you. Right. We'll have to end this. So, what did we do? So, what we said is, okay, here's our operating system, here is our program. So we said, okay, please execute this program. I'm sorry for the quality. This is just, yeah. And then this program basically goes down its list and makes a lot of functions. So function, and then it executes sub-functions and sub-functions, and at some point these functions end, and then it executes the jumps to the parent function. It executes the parent function until this ends, and then it jumps out and back to the main function. So this is called this is the main function. The main function is basically just a convenience function. You could label this whatever you wanted, but the default is that you use the name main so that everyone knows it's the starting point where your program basically starts. And then if the program has ended, it returns basically control back to the operating system, and that just does whatever it does until you shut down. Right. So the next thing are variables. Variables are basically you want to store something for an intermediate time. So it's not like you're storing it on disk. It's if you execute the program and you don't save what you have inside these variables, they're gone. They don't exist anymore. But they are very, very fast and good for intermediate storage. The way you use so if I haven't explained it, this just prints something out to the standard to the console. I hope this is clear. Yeah. So the way to declare variables is by using the let statement. Let is basically something I think it's based off of math. So where you can say let q equals b this and this and this. There are other identifiers. There's just an identifier like const. For example, constant like pi equals 3.14. We will just say let pi equals 3.14 because there are some difference between let and const. So if this is still a valid program, it is recommended to use small letters and underscores for your variable naming. So here we just say, hey, we have a variable called pi, and it has the value of 3.14. Now, what I need to talk about are basic variable types. Right. And the way to do this is by saying, okay, we have a variable types. Oops. Let's just say variable types. Rust is a very, very strongly typed language. So what does this mean? So if we have, say, x equals 3.14, or in this case pi, but here's just x. And later on we want to say x equals hello. These are different types. So this is a string, some form of characters that are formed together to make some sort of letters. And this is Rust does also differentiate between floating point and normal integers. These are called integers, where you just have where you don't have decimal points. These can be very, very useful. And then you have strings. These are like the basic, really, really basic types. And then from these types, there are different versions of these types, right? So again, if you have questions, just put them in the chat. There are different versions. Let's just draw them out here. So what computers basically do is they have like a series of 0, 1, 0, 1, 0, 1. And what Rust allows you to do is to say, okay, how much memory should be reserved for these 0 and 1s. So if you have 8 0 and 1s, this number is going to be 8 bits long. So if you can imagine, okay, we have 1 in binary, 2, 4, 8, and so on. So the largest number that you can store in an 8-bit number is 256 in decimal. 8 binary is 256 decimal. So that's when you set everything to 1. And so 6, 7, 8. So this is 256. Now there's a problem. How do you know that it's 256? How do you know maybe this should represent a negative number? So for this, the numbers are split up again in unsigned and signed. So they either have a sign or they do not. Now you can interpret an unsigned as a signed integer, and that's a source of a lot of bugs. So you can say, okay, this is not actually 256, this is actually 128, but now what you can do is say, okay, 0 is not equal to 0, but 0, 0, 0, 0 is equal to minus 127. So minus 127 is because 0 itself is a number. So if you have 0 itself is a number, so if you have minus 1, 0, 1, 0 is an actual number, and in this case it would be in this in an signed integer, it would not actually be in an unsigned integer. This would be 0x 0, 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. But in a signed integer, this would be something like I think 0x 0, 0 I think this would be 0, 1, 0, 0, 0, 0, 0, 0. So that you this would actually be the value of 127, so that if you count from minus 127 plus 127, you get 0 in decimal. So that's just, and Rust does differentiate between these types. These are not actually different in memory. And these are not different in memory, but they can be interpreted in different ways. So, come on. Right. So this is what we can do. Now to say, Rust, that you should use a specific type, you can add after you have the variable name, you add this can have spaces on or it doesn't, so you can add a colon and tell the data type. Now the convention for this is that unsigned starts with an U and signed starts with an I, because I for integer and U for unsigned integer. So now the problem is, alright, but this cannot possibly work because here we have a floating point number, and I just said that integers do not have any floating points. So if we remove the floating points, actually if we tell Rust again, okay, this step of transforming your file into a executable is called compilation, and this step is to compile a file. So if we say, okay, Rust, please compile this file again, it will first of all get say that you have some syntax errors because I should remove these things because Rust doesn't know what to do with them. But if we just compile this again, we say it found a floating point variable. So Rust errors are actually pretty good. So you need some floating point variable. Now what Rust does is it says, okay, if you don't have this, I will provide you with a default default type. So the default type for floating point variables is called right, F32. So in this case you have a floating point variable, and it's 32 bytes long, and that's a lot of bytes, but it might not be accurate for everything that you want to do. So if you're basically calculating some star or some really, what you have to know is that as a floating point value increases, the precision decreases. So if you have say a very large number, and then you have a let's say just one decimal place, this will work. But if you add more decimal places, at some point the results become inaccurate. So you always have to watch out for this. And with 64-bit you have more precision, but therefore you need more memory. So this is floating point variables. So if we just see this, so the types are 8, 16, 32, and 64. And for each one of these you have U8 and I8, U16 and I16, U32 and I32, and U64 and I64. I don't actually know if I64 is, yes, it is I64, yes. So these are the basic integer types, and all you have to do is to say, okay, how long are these types in memory? And the compiler has to go and check if these types do actually match the correct size. Right. So for floating point there are only two. There are floating point 32 and floating point 64. So this is rather easy to say. So if we just say F32 and then I close the terminal, right now it does warn me that we do assign something to this variable, but we don't ever use it. So you can turn off these warnings, or what Rust does let you do is you can use an underscore in front of the variable in order to say, okay, we don't ever use this. You don't even have to give a name, so you can just say let underscore, and this will work, but it will turn off this warning. So if you use underscore at the first character of the variable name, you can you basically say the compiler, okay, we don't use this. Please don't look at this. Right. So that's these are numbers. And the next thing that we're going to look at are letters, because letters are more complicated. So what letters actually are is that they have individual codes, and you can see these are the default, these are the American standard character, I don't know, ASCII characters. So if the computer thinks that a certain variable a certain number is actually not a number, but it represents text. Then, for example, A is the character 97, and B is 98, and A is 65, and so on. And there are a number of unprintable characters, many of which may not be used, and some that are used for drawing like decorations on text-based interfaces. So these are strings. They are called strings. Text, well, it's a collection of characters. Rust does have individual characters, and it has strings. So and to explain what the problem with strings is we have to actually go and look at the history a bit of strings. So strings are like hello. Now, for the most part, if you look at this table, it uses up until 256 characters. And that's okay if you're living in an English-speaking country, but many people do not. So what you already have is an encoding. You have to specify, well, what lookup table do I have to use to get to the actual value, because 230 is just a number. It could be anything. So the encoding, you had ASCII, then there's also ANSI, then you have various other, like Latin 1, which is used in West Europe. You have DOS, you have IBM encoding, and each one of these uses different tables just for different countries. And this is generally a bad solution, because what if you want to send someone else a document in another country, and now he has to know about what the DOS IBM encoding, what this actually means. So in order to solve this, there was an effort to create UTF-8, which is a universal. There are several versions. There's UTF-8, UTF-16, UTF-32, and what the effort was is, okay, we want to know which one of these what is the actual letter, regardless of this table, and it has to somehow automatically figure this out without even without using a translation table. So it's a known standard. So what Rust did was they simply said, okay, most languages like C, they just say, okay, a character like C, this is 8-bit. Now, Rust doesn't say this, because what if you have some weird Chinese symbol, and this is not 8-bit, but this is suddenly 16-bit, and this is suddenly a bit longer than the usual characters. So if you would read this from, let's say, a C program, you would suddenly get something like and something like this, even though this was the original character. So this is the problem with encoding, because UTF-8 knows how long the character actually is. If you have, if you say it's UTF-16, which means that the character is at most 16-bit long, and there's also some sort of text compression going on because storing you can store differences between characters and so on, but the basic thing about Rust is that you don't have to worry about this. So Rust is UTF-8 by default, which many other languages are not, which is something that you might draw into consideration. So you can have, these are called multi-byte characters, and especially if you have something like C and then the Chinese symbol, that's intermixed characters, so one is 8-bit, the next is 16-bit, and so on. So this is what Rust does. Now, in order to understand, so what is the data type of this string? If you put this in quotes, it will regard it as a string. So what is the data type? So what is the data type of this? Now, what you have to understand is what I said in the beginning. So a program, just, oops, this is a bad color. A program just has the operating system which calls in your program. Now, what this program actually contains is that this program is just a file. And what Rust does is it says, okay, if I already know what this value is going to be, like whatever, I am just going to put whatever here inside this binary, so it's always loaded when the binary gets loaded. So I can use, so I can refer to this whatever string from anywhere inside here. So I can use here, hey, what is this? Hey, I wanted to access this string actually, and this is called an str. This is an str. Rust has two types of strings, and we will get to the differences later on. Now, what are these? These are these things, right? These are instructions that refer to the original to this string, right? So what's actually done is, if we would say hello2 equals hello string, that there might be some implication, but just for the sake of this example, and then we would have something like hello3, and they all want to access this string. Now, what you could do is just go ahead and copy paste it every time. You could write whatever here and so on. But what if this string was really long, and you can actually do this? You can include whole other files into your binary so that you can that you always have them loaded. Now, it would be somehow wasteful to just copy and paste this over and over again, because what if you refer to this like 50 times, and then it's 50 times whatever. So this will bloat your binary size. So, and the general way is to say, okay, we use a reference. A reference, the symbol for a reference is basically this, and I will get to in what a reference actually is later on. So a reference is an ampersand sign. In most languages, it's like C does not have references. C++ has references. And what this is okay, we know our location here, right? We know the compiler knows what the location is. So from this location, please jump back like 24 instructions or some value. Let's say 50,000 instructions happened before we had this, and then we had this. Okay, so the this is a bad color, and I should just delete this. Right. And then we'd use this. So what Rust says, okay, here is our .exe. And here it has, here's some data in the exe that describes how the exe should be processed, handled, if it has an icon or not, if it should make a window, and so on. So then we have the instructions, what the program should actually do, and then maybe some metadata, how big the file is or whatever. And what Windows or any operating system does is it just starts here and then it goes down the list, right? And then here we have something like our string whatever. So a reference is basically just, here's the start of our binary, and then here is the end, maybe some maybe some large number, and then here is the reference just says, okay, the string that I actually want to get is at location maybe 0x12 or something like this, right? 0x just means it's in hexadecimal, so it's basically like a short way to write a binary number. And then here at 0x12, this is where our actual string is, right? This is where our whatever string is. So instead, and then the next instruction can say, hey, I also need this. Please jump to 0x12 and get me whatever here is. And then it uses this, and it can be used again. And so instead of duplicating this whole thing, this is called a reference to this location. So it's a reference to a location where you can actually get some data going on. So if you want to find now the last type I didn't actually talk about because it doesn't appear here, because but in Rust everything has like a value. So this if we say let hello string equals whatever, this whole thing actually has a value, and this value is called void. Void is just nothing. So for example, the main function, no, I didn't talk about functions yet. but this is just this assignment. This is called an assignment. We assign whatever's here to here. So this is a value equals this, and you will often see this as being the left hand side, or LHS value, and then it's the right hand side, and this is an assignment. And basically we this is a symbol now for this value. I think this should be pretty clear. So now if you want to find out what the type of a variable is, and you don't know what you should put here, right? The easiest way to do this is to let the compiler tell it to you. So if we just say let's hello 3, and then we annotate it with a wrong type. Let's say f32 equals hello string. So this is clearly an error because this is not a floating point value, and this is a string, but we don't know what this is yet. So we just let the compiler give us an error, and in this error it will actually tell us what the type was. So expected f32 because we have said that we want an f32, but we got a reference to an str. So this is called str. This is in Rust. In other languages there are weirder rules, but this is an str. And an str is basically a collection of UTF-8 characters. So Rust does also have a special type like char, but char can only store one single character. So if we just put this here, right, and then it expected in char. So char is another data type, but it can only store a single character, and this character must be an UTF-8 string. It's not like if you come from C, this is not often in C you use the character and the U8, so the 8-bit number, interchangeably. This is in Rust, it's not the case because this has to be an actual UTF-8 character. A valid one, right? And there are rules on how to create UTF-8 characters and so on. Again, if you have questions, please just put them in the chat. I'm checking again from time to time. So we know that this is a character, and I'm also recording this. So if you came later on, you can rewatch the video on Twitch. So next thing I wanted to talk about, there is a third data type. So we have covered, so far we have covered, right, we have covered regular integers, we've covered f32 and floating point types, we have covered characters and what these are. We've covered that we have a void type, which is just, a void type is nothing. You can not do anything with it, but it's often used as to say, okay, this this a function can return nothing. It can just do something and then return nothing. But we will get into functions later on. And we have two types still. Two types are still outstanding, and these are the fundamental types. These are true and false. And despite what you think, these are 0 and 1, but these are not actually 0 and 1 in that you have just one bit, but these are actually 0, 0, 0, 0, 0. These are actually 8-bit long, and 0, 0, 0, 0, 0, 0, 1. So this represents well, it depends on what you define as true or false, right? It depends on if you want 1 to be true, you can. If you want 1 to be false, you can. So it's up to you. So the compiler says, okay, let's say today is Sunday, and we want to check if the deli is open. And this would not be the case, so we just can say false, right? So false and true are special keywords that instruct the compiler, okay, this is either false or true. The last data type that is not really important, but you should know about it is the exclamation mark data type. But this is a bit confusing because what main actually does is it exits the program. So right, now I have to talk about functions first because we need to talk about return values. So if we have something like this, let's see, we have a, come on. Oh yeah, I didn't turn it on. We have something like this, right? We have our operating system which calls our program, and then this program starts executing something. Right. Every program that you will ever write is built up on functions. Now, these might be called routines, these might be called instructions, but in essence, every program just goes from a list of instructions and executes them in order, right, from top to bottom. So, and a function is a way to say, okay, we could let's say we want to calculate the square of 5, right? So we could just say, okay, let result equals 5 times 5. Right? And this would be perfectly valid, and we would not need any functions. Now, but if we want to say, okay, we want to get the square of 10, or we want to get the square of 12, and then we would always have to remember, okay, this is the times. We take the value and take it times itself, right? So what a function is basically an encapsulation of this code, because 5 times 5 in itself is some expression. It's called an expression, And this is also an expression, but it's often called a statement. I won't go into detail of expressions and statements here later on. Maybe later on. So, functions allow us to encapsulate certain behaviors. So, the way that functions work in Rust is you have the fn keyword, and fn and then what your name of the function is. And here you can give the function arguments. So we can say, this might be better to do in actual code so that I can show you. So fn calc square, and then the x, what this should be, and then what it should return, what data type it should return. Again, Rust is a very, very statically typed language, so you have to annotate both what you put in to a function and what you get out. In some languages, you can just write, okay, calc square x. So the language will try to do whatever it can to sort of guess what x should be. But the problem that Rust tries to solve is to not do any guessing. So you have to, same as you have to do here, you have to say, okay, x is of data type unsigned 32-bit integer. And so Rust knows, okay, we get a 32-bit integer in, and it's also unsigned, so it can't be less than 0. And well, in this case, you might take the you can take squares of negative integers, but yeah, that's just math. And you return this single arrow. This is like a I call it a thin arrow, but you can call it whatever you want. This just says, okay, please, this is the return type. So once the function is done, right, so at some point, right, we call now a subfunction, which is calc square, right, and it takes the x from the parent function, and then it has some instruction here that says, okay, get me whatever was called in the parent function. Then I will do my calculation, and then I will say, okay, I will put the result somewhere here. And again, since the parent function needs access to this must be this this value, the size of this value, what this returns, must be known at compile time. You cannot just, it's not magic. You just have to say what type do you want to return, and both of these are stored here. I think I might be wrong on this one, but they are stored in the parent function. And once this parent function is done, all of these variables get overwritten with other stuff, and then memory is freed again from the computer, right? So you always have to tell Rust what the function should return. Then you can use curly braces to open the function. So if we now try to execute, to just compile this program, we have not actually used this. But if we just try to execute, compile this, Rust will always oh, it doesn't actually, maybe this was removed from the language, then my knowledge is a bit bad. Right, so the error is, okay, Rust says, okay, you wanted to return an integer 32, but you return nothing. And nothing is just this void symbol. So these two braces are they are called void. So you don't return anything. And so what you can see, what you can say is, okay, return, which is a keyword in the language, return x times x. And then you have to make a semicolon. Now, if we try to compile this, yes, it warns us that these are never used, but it compiles just fine. So if you see red, it's an error. If you see yellow, it's okay. Right. So what Rust says, okay, this return x times x is maybe a bit redundant, because what Rust does is it says, okay, the last statement, this is it's not a statement, but okay, this statement, return x times x, right? This is a bit redundant. So what we can do is, in the last statement, we can both remove the return and we can remove the semicolon. And this will be the exact same code as previously. It's just a bit easier on the eyes. So if we have this, right, this is the same code. Now, the return type can also be void, right? So we can say, okay, this function calculates the square, but it doesn't return it back again. So what we can say is, and this would compile fine, because the default, if you leave this out, if you just say this, then this will be inserted by the compiler. So the default return type of any function is void, unless you say otherwise with these thin arrow type. Cool. So what you can do is you can say, okay, right, x times x. So so you can say square of 5 equals calc square of 5, right? 5 is an I32 integer, and then this is wrong, this should be I32. And then we have the calculated, written a program that can calculate the square of 5, right? I don't think this is very hard to understand what this does. So now we want to actually see the result of this calculation, right? Now what you have to know is about format strings. So if we have, this is something that is that originates from an older language called C, very widely used today, but I don't want to get into differences now. No, this was not what I wanted. Yeah. So if you print something out to the console, so if we here are we, and we are executing our program. Now we want to see some output here. But which format does this output actually have? Well, this output is actually a string, right? So what we have is a number 5. Let's say we have 5, but then we want to get to the string 5, right? 5. And these are different representation, because if you look here, the number 5 is just inquiry, whatever. If you would print this out, you would get some spades symbol, right? And this is wrong, and of course we want to get the string 5 and not the actual number 5, because this couldn't be output here. So what Rust does is, of course, it has conversion functions for just translating from a number to a string. Now, the problem with these conversion functions, maybe you would see them in your C program, like I to A, integer to A to... I don't know what this A stands for actually. And D to A, which is double or floating point value, D to A. But these are used by Rust internally. But what C, I think, invented was the formatting string. So after we print, we want to print a line. Now the problem is that once we are here, there's another invisible symbol called the return code, which just says, okay, jump to the next line, please. And this code is often referred to as _n. So what we actually have to output here is, say 5 and then _n, right? Now what C did is it made format strings. So in C, the function for doing this is called printf. And then it has these special symbols, like the percentage and then a D, and I don't even remember these. And then you can add your parameters here in the I didn't draw this very well, but you can basically put your number in here, and then C will use this formatting string. So this is a formatting string. Right, so it will use this formatting string to format the number that was put in here in place, right? This number gets put in here, and then we use the format string to actually generate the actual string, and then we use the operating system dependent functions to say, okay, I want to actually have this 5 value appear here in this place, right? Now what Rust did is, okay, many people often don't see any output because they forget this -n. So what Rust has is both print and it has print line. So print line is the more commonly used one, which just inserts this -n at the end, right? So and print doesn't do this. So if you use print, you can use it. It has its use cases, but it's less. It's rare. So you can use this print, but this won't actually put anything on the screen yet. But this print line does, so it's kind of more commonly used. Now in Rust, the formatting is not done by percentage signs, but it's actually these curly braces again. If you have syntax highlighting on, you can see that this just turned yellow. And if I say the square of 5 is, and then here I can add my number. Let's say that we just calculated square of 5, right? And so we call, whoops, sorry. Alright. So we call this function, and then we just say, okay, the square of 5 is, and then we display the square of 5. And this thing has multiple options how to format it. For example, you could pad this result, which will be 25, of course, but you could pad this result so that it says, for example, maybe you would want to have it not display as 25 but as 0000025 in order to have some padding so that it lines up with other things that you just print out, so it looks nice. Or maybe you would want to have a tab character, so a tab character is just so if we compile this and then execute it again, the square of 5 is 25. And this is correct. The square of 5 is 25. So this is really the basics of using Rust. Now, I will be doing this, we have 50 minutes left. Now, the next thing I wanted to teach, again, if you have questions, please just put them in chat or so that I can see them. But this should be fairly easy to understand, but you just have to practice it a bit. And again, if you forget some of these semicolons, this can get, this may be a problem, but Rust actually, oh yeah, because this didn't return anything. But yeah, in this case the missing semicolon was actually fine, but yeah. So it will tell you, so learn to read the error message. So it says, okay, print line, I don't know, suddenly for Rust the white space is not important, so for Rust this just is the whole program, and then suddenly you get a print line where he expected a semicolon, right? So this is why you get an error, and it says expected one of dot, semicolon, question mark, or an operator. So if you want to have calc square divided by 3 or something, you could do this. But if you just say this is wrong, right? So what should be the next thing to go about? We so just wanted to show a formatting strings. So there are various what this actually does is that each one of these types has a display function. Again, this macro just calls a function, which is, this is pure pseudocode. I don't know if this is actually implemented this way, but display. And this function says, okay, this is a type, so if we have, this is actually calculated as 25, display, and this display returns then the string of 25. And then it concatenates the 25 with the rest of this thing here. But you could also say, okay, this is one of the most useful things I've done about formatting strings. You can format it to up to six characters. So, and fill it with the 0. Now you have to go into the documentation on how to actually use these kinds of things. But if you just wanted to see how they are useful, so this is padded out to 6 characters. So 1, 2, 3, 4, 5, 6. Now if I have a smaller value, let's say 2, and I still have this 0, 6, so the 2 is 4. So you see they still line up. This just got padded with an extra 0. So this is where these are incredibly useful, because it's nice to look at something that's padded out this way, right? This is much easier to look at and to compare. Yeah, so the next thing we are going to do are loops and if statements. Now, if you would just run functions, this is fine. But this is not how a computer works. So, well, it is how a computer works, but let's just say we don't actually want to print anything out here. So we have this square of 5 result. We have this square of 5 number. So what we want to say is, okay, if this square of 5 is larger than 20, then again, print line, you are larger than 20, right? And else you are not larger than 20, right? So what we have here is called an if-else statement. So if I've told you about the true and false value. So this, whatever put in here must result in a true or false statement. So we can say, okay, square of 5 larger than 20. Internally, this will actually compile down to square of 5 dot larger than 20, something like this. But this is more easier to write, I think. So you can again use these curly braces to mark off this region. And if this is true, then this will get executed, else this will get executed. Right? I hope this is somewhat understandable. I don't know, it's basically like English. So you have to say if I'm going too fast, it's just that so you are larger than 20, right? Because 25 is larger than 20. So let's say we want to test this value for multiple values. So what we have to go and do, else just gets executed on every if this is not true. Now, what if we have something more interesting? Let's say we want to have a square of 5 larger than 20. Larger than 30, larger than 20, and then check if the square of 5 is larger than 10, right? And these things can be accumulated into a bit shorter way. So you can write else if. So you first test if the square of 5 is larger than 30. Then you test if the square of 5 is bigger than 20. And then you can say else, okay, it's neither larger than 30 and it's neither larger than 20, meaning it must be some value below 20. So, and this is you don't, in some languages like C, you have to use these brackets around here. You don't have to do this you don't actually have to do this in any case, but there might be some ways where you think that braces are more clear. Again, this does not add to any compile time. This is just to any runtime or how slow or fast your program is. This is just more nicely to read. Right. So what you can also do is you can use a match statement. So in other languages this is called a switch statement, but in Rust this is called a match statement. So we match the value of square of 5 against some other value. And if the values are the same, then we execute whatever we want. So match square of 5. Now this is actually a bit tricky. So maybe you have some number crunching going on and you're doing some heavy computation and you want to see, okay, in what range is square of 5? Is it larger? Is it somewhere in the range of 40 to 100? Is it maybe in the range of 40 to 20? And so I didn't show you this, but the way you would do this in the traditional way is say if square of 5 is bigger than 20, and then use double ampersand. Double ampersand means the and symbol. You can also use or symbol. So if either one of these is false, you can use the hat to say, okay, one of them I think, one of them is true and one of them is false. So you can combine multiple statements, multiple booleans together. Again, you can also just pass true in here and false, and then please execute this, right? True and false. Again, this must be true. So this will get executed, and if false, get skipped, right? So the way you would do this is to say, okay, if something is in the range of 40 to 100, if square of 5 is larger than 40 and square of 5 is smaller than 100, right? then it must be in the range of 40 to 100. We don't know what number it is yet, but we know that if this is true, if this evaluates to true, then it must be somewhere in the range. So, and the match statement is often very useful for these kinds of ranges, because what happened is that these sort of comparisons are incredibly common. So what Rust did is said, okay, we make a shorthand notation for this. So we just say match square 40, then a double colon, so 2 colons, and then 100. So from 40 to 100, and this way you don't get accidentally like this. And you know, if you're in a larger code base and something like this comparison, this is very hard to catch, right? But this way you always know, okay, 40 to 100. Now, the syntax for this is, again, these are abstractions over the really low level stuff, but it's just more convenient really to use, right? It doesn't have any overhead or your program suddenly runs slower. It's just more convenient to use. It can actually run faster this way. So what Rust did is say, okay, we have this called the, I call this the fat arrow. Oops. Right. The fat arrow, and then this is the thin arrow. I don't know if these are the correct names, but I just say that they are. So what we can say is print line, you are in the range of 40 to 100 somewhere, right? And what you can do now is to say, okay, maybe we want to test if it's in the range of 100 to 200. And you might, 100 to 200. So what you might say is, okay, but we can't test against every number, right? And if I actually try to compile this, in this case, you don't put the semicolon here. You have to put a colon here, because these are like, I don't know why this is, but yeah, this is just something that in this case you don't actually have to put a semicolon, but a colon here, so that this I think the rule is that this is still in the statement of match square to 5. And if you would put a semicolon here, this would not matter, but this would be okay, but don't put a semicolon here. Right? But the actual error I wanted to get at, oh yeah, this is the experimental, but this is a bit tricky, but just for demonstration, I did not realize this, but this is still something that's fairly new in the language. So yeah, this is called a match expression, and then this here is called a pattern. So a pattern is anything that can, right, maybe this would be a string, and then the pattern would be if the string is hello, write hello. If the string is iced tea, then write you shouldn't drink this, or something like this, right? And what Rust complains about is, well, he doesn't know what to do if none of these are, what happens if square of 5 is not is neither 40 to 100 and 100 to 100. What should it do then? So what you have to say is, again, I've said this previously, that if you prefix a variable with an underscore, it gets ignored. So what Ross did is said, okay, underscore also stands for whatever value is input in here, and you can just put empty braces in here. So this will do, this statement means it just does nothing. And if we just compile this, yeah, I didn't save, sorry. Right. So if we execute this, we don't get any output because square of 5 is 25 and 25 is neither in the range of 40 to 100 nor 100 to 200. But if we just go ahead and say 10 to 30, then we can say 10 to 30. And again, this was maybe a bad example, but you're in the range of 10 to 30, right? I have to close the door, sorry. Alright. Now what you can do is say, okay, this square of 5, so if this value is 25, it says, okay, you are exactly 25. And now what's interesting about this is that it doesn't evaluate this thing anymore, right? So if you have something like this, you can just put the more generic one up top, and then it will say, okay, this is an unreachable pattern because the 25 is the number, and then it will print this and then return here, and then return here. So it won't actually do this, and always listen to the compiler. The compiler is incredibly helpful with this. But what you again, this does work on other things as well. So if we have a jam string which has the value of jam, then we match the jam. Okay, is this honey? Then just say, okay, this is not jam, right? And if it is jam, this is jam. Just say, right? And if it's neither honey nor jam, then we just say, we could say unknown. And we compile this, and it says this function is never used. Yes, we never used this functions, and it says yummy because this is jam. So you can match on various other things as well. Again, this is just if we have this and this are the same, then it will execute this. And if you have larger blocks, you can actually put this in multiple lines and so on. But if you just have like short functions, right, and it outputs this yummy yummy yummy. I should maybe make the font a bit a bit a bit larger, so right, so you can easily see it. So this is what, yeah, this is pattern matching. Now the last thing, we have about 20 minutes left, about 20-25 minutes left. Next thing is loop. So if you say here we have printed yummy 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 5 times. So the problem with this is that we have now, maybe we've made a typo and this was not yummy but yummy or something like this. So what we can say is for in 0 to 5 and then print line and then yummy, right? So for underscore, this underscore is a counting variable, so it's an index. It's often referred to as I, because I maybe integer, maybe index, something like this. But and this is called a range. So from 0 to up to 5, and the low you can, I think, also go from 5 to 0, but you can't use floating point numbers here, because floating point numbers have infinite amount of steps between each value, so you can't use any floating point numbers, because you don't know what the actual stepping should be, right? So you can only use integers in these ranges. This is called a range with this 2 dots in the middle. And since we don't use the I, we can just say underscore, right? And if we compile this, it says, okay, these were not used, but yeah, it has the same output as before, but I didn't copy paste all of this. So we repeat the whole thing and have it print out. Again, this would be really bad if we had something like 50 times. Right? And now it's printed this out 50 times. And so if we would have copy pasted this would taken us way longer. So the general rule is 3 or more, use a for. So if you have more than if you're copy pasting the same stuff more than 2 times, use a for loop. Generally that's the rule. Now oftentimes it's beneficial to have something always running while some other value is not true. So let's, for example, if you have a window open on the screen, you actually have something called the window loop. So if I have this window on the screen, this is actually running a loop, and this for is called a for loop. So it loops always around and around and does the stuff in here. So we could also run cork square 50 times. So and in this window loop, you must check if the window should actually close. Because if the window should close, you should exit out of this loop. Now you can say, okay, we are looping 50 times because we want to maybe we get more than like 50 events or something, and we want to keep the window open as long as the window is not closed. So we can just say let is window closed equals false, and then we can use a while loop. While we can negate the statement with the I wish what this symbol was called. Well, we can negate this while the window is not closed, and then say, okay, print line yummy, and this will in this case will run forever. But if you have something like this saying, okay, if event equals escape, then is window closed equals true, and then the next time the loop will run, it says, okay, this is window closed is now this not window closed will be false, so equals to true. This part is automatically put in by the compiler, so you can just say while not is window closed, right? And then we set the is window closed equals true. The loop will go around here and say, okay, not true equals false. So while false, then I will say, okay, we will exit this loop and continue here on and print this yummy thing, right? Now the window is not closed. Now what you have to see is this. So in this case we run the loop exactly one time, right? We say here it's false while it's not, so we negate the false, so this is true. So the loop enters here, it says window is not closed. Now we'll actually remove this, and then it goes around here, loops again, says okay, this is now true. We negate this again and say okay, we exit this loop, we go into the next loop. Now let's see what the actual error is here. Right. So by default, you cannot just say that that this is window closed can be reassigned again, because that can be the source of a lot of bugs that you might not want. Maybe you did not intend to immediately close the window. So you cannot do this. So you especially have to mark a variable that it can be changed later on. This concept is called an immutable variable. So if you see something like this, you cannot change it. You cannot say is window closed equals true, because that would change the value that is in is window closed. To make a variable changeable, you use the mute statement. Keyword, sorry, keyword. So now what we say, okay, this is window closed is false, but it can be changed. So now what we get is a regular window, and it says yummy 50 times, and it says window is not closed exactly one time, because well, I explained it. So this is the concept of mutable and immutable variables. You can only change something if you mark it as mutable. Other languages automatically set every variable you declare as being mutable, but in Rust this is not the case, and it has its reasons. And this is also a performance optimization. So if you say this is immutable, then the compiler can do certain optimizations and it will actually run faster, I think. Yeah, maybe not. So 15 minutes. So the last thing that I wanted to talk about are structures, and structures are composite types. So if we in itself we have only encountered like in itself we only have true, false, right? These are Boolean, called Boolean, and their type is called bool. I should make a new. No. Right. Their type is called Boolean, and they are. So we have a bool, which can be either true, or false. Then we have the I and the U family for signed and unsigned integers, which can be, well, in the U family, right, like U8, U16, U32, they can be, so this is U, this is I. The U family can be, for example, -1, but the unsigned, they can't have this signed. So in the unsigned, this would actually be then 255, because by default, if you subtract something and it's called an overflow, if you have something like 0,0,0,0,0,1 and you subtract like no, this was a bad example. So in the unsigned word you have 5 minus 16, right? In every regular word, this in the signed word, this would be -11, right? If you have an I8. But if you have a U8, you cannot go below 0, so this would actually wrap around at 200. It would first subtract the 5, which would be 11, so this would be 256 or 55 minus 11 equals 245. Yeah, so this would be, it would wrap around at the end. So then we have the string family, which has str. We will get into other types of strings later on, because there are rules and regulations on how to use them, and this is basically hello. Then you have the F family, which is F32 and F64, and this is 5.0, 3.14 and so on. And these are called primitive types. Primitive. Primitive types. Because the compiler exactly knows about them and can. So this is where. So these are composite types. So what you then can do is, okay, you can maybe have a maybe you have a window, right? You have a window, you want to have some graphical application on the screen. Now what you have is, okay, you have a window width, window width, which is maybe a unsigned 32-bit, because you can't have negative height, and window height. And what you start to see is these somehow belong together, right? They should not be separated from each other, because you can't have a window with a width but not a height, right? So here's where we draw the line between primitive types and custom types, or maybe composite types. Now the way you do this is you say, okay, we have a variable which is of type, not of type U32, but of type window. Let window and this is better if I just type this out, right? So these are called structures or classes, or they're not really classes. There are differences between classes and structures, but this depends on your language. So struct window, and then we can say, okay, this width has a and a height. So right. Now what we can say is, okay, Rust does not allow this. So what we can say, this is not a primitive type anymore. This is a structure, and the structure is made up of two separate types. In the end, in the binary, this does not matter at all. This will get removed by the compiler later on, but it is very, very useful for us to have some. So we have a window with which has a width and a height. So we can say let window equals window. Maybe I should make this more clear. My window equals window, and then we have to say, okay, what is the width and the height? So we maybe have a width of 500 and a height of 300. So this would be a window. Now what you notice, what is the type of the variable type of this my window variable? The variable type is actually of type window. So this window is not something that Rust that is built into Rust, but that we just have made. And in other languages you would have to put this on top before you actually use it. Here you can just put it here, put it everywhere. It doesn't matter where this window is. Rust only has to find it. So as long as it's in the same file, and Rust will find this, and will go about of modules and scopes and whatnot in a later video. But if we compile this again, right, this is, it says, okay, we never used this, but let's but if we want to get the my window width is, and then we just say my window dot width, right, and this dot means that, okay, we now have this variable and we want to access the field. This is called a struct and a structure, and this is a structure field. So we want to access the width and the width field of this, right? So my window width is 500 because we said that it's 500. Now, what's interesting about Rust is one of the benefits that I've not seen this in any other language. Yes, maybe Python. But what you can say is, okay, if this had more fields, maybe it's a again scroll amount, how much the user has scrolled or something like this. Maybe 5,000 lines he has already scrolled. It's a long Wikipedia page, and so we need, this is called the declaration, and this is when you actually, the instantiation. So when you actually make an object, this is often referred to as an object, but if you make when you instantiate, this is more like a template, and this is the actual instantiation. So you're actually making a window. You could make another window, right? Maybe with the same with other variables, but it's still of type window. So if you make something of type window, it's called the instantiation of the structure window. So you're making an object of type window, right? So what now? Here we now have two windows, and we want to print all of the variables, like the width, the height, the scroll amount. Now what we have to do is to go here in and say height is height, and this is a lot of repeated unnecessary code. Scroll amount is my window dot scroll amount, and then we would need to copy this again and make this for the other window. And this would work, but it's a bit long to type, right? My window, you know this, right? Now what Rust allows us to do is, this is something that I have not gone into much detail, but it allows us to derive things. And in order to understand what this means, we would have to go much more in theory, but this will be done in the next episode or a later one. What Rust allows us to do is to say derive debug. Now what you've maybe already seen is that when I say print line, it inserts this question mark here, this this colon, double colon, and then this question mark. And this question mark tells to print the debug version of whatever is passed in here. Again, these are numbered, so if I could say here, then I need to pass in a second variable. This is how you print multiple variables, but on the same line, right? So what we can do now is to say, okay, what Rust says is, okay, we can already print the debug version of the width. We can print the debug version of the height. And we can print the debug of the scroll amount. What this means is that we can just print the debug version of the whole window without you ever writing some code that looks like this. And this is really, really convenient, which is why it's called debug for debugging. So basic, yeah. And what you can say is, okay, my window is, and then you have these question mark, and this is a formatting string, and then say my window, and then you can say other window. Now if I execute this, then it says, okay, my window is window, and then width, height, and scroll amount, right? Just like we've laid them out here. Now if you enter a pound sign in here, this will this is the symbol for, again, I don't use these on the top of my head. I always refer to the documentation, but I've used these few strings so often that I've sort of remembered it. So right now it's much more readable, right? My window is window with height, scroll amount, without us writing any of these codes, actually, any of this code actually, to actually print this. And this is something that I haven't seen in other languages, so it's fairly new. So to recap, today we've gone about how to make basic variables, what the data types are, how strings are done, how numbers, how you can print something, how you can use if-else, how you can use loops, how you can use match statements, and how you can use structures and then print out the debug versions of these structures. So I think for a first 2-hour transition into Rust, I think this was hopefully a bit helpful, and I hope you learned some theory. Maybe it was a bit too basic, but well, I didn't want to skip ahead and leave other people waiting. So if you have any questions, please just put them into the chat, and something was unclear or something. Otherwise, you know, I'll wait a few moments because the stream is usually lagging. So if you have any questions, just put them, just put them down. And wanted to say, right, so I'm uploading all of these again to YouTube, and you can also use Twitch if you want to reiterate on these concepts. You can re-watch them after the stream, or you can use I'm always uploading these videos, so you can go to YouTube. I will put the channel into the description, right? And yeah, I hope you enjoyed the stream. Again, if there are no questions, I'm going to end this, and again, rustlang.org is where you can start. Right? I'm just waiting for questions now. Alright, if there are no questions, then I will end the stream, and I hope you all have a nice evening. Thank you.